Hi, I am Andy Slippy. I'm a senior engineer here at Advanced Cooling Technologies. And today's question is, what are the benefits of pump two-phase cooling over single-phase cooling? So this is a very basic schematic of pump two-phase. You have a pump, an evaporator, a heat exchanger, and a reservoir. You'd have a very similar loop if you had a single-phase loop as well. The main advantages of the two-phase loop come from several things. So one advantage is isothermality. That comes from the fact that you're boiling the water it's not water, it's coolant, as it goes through the evaporator. So the evaporator would typically be like a cold plate with some sort of devices on it that you're trying to cool. And so as you have these random devices placed throughout here, as coolant moves through here, if you're using single phase, that coolant has to heat up as it takes the heat from each of these devices. In two-phase, the heat is taken by the evaporation of the coolant, and so the temperature remains constant as it goes through there. So that allows all these devices, this device at the end is no hotter than the device at the beginning. In addition to that, with isothermality, you can control the temperature very well because the temperature that you're boiling at is a function of pressure. And so you can actually add a device here that would regulate the pressure here without regard to what's happening in the rest of the loop. And so the pressure would be there, so the temperature that you're boiling at remains constant and allows you to have isothermality over time as well as space. The next advantage is a reduced flow rate, again because you're boiling the fluid. The latent heat capacity of the fluid is much, much higher than the specific heat capacity of most fluids. And so as you're moving through, the amount of coolant, like the mass of coolant that you need to take a certain amount of heat is less. So that brings a lot of advantages depending on the rest of the system architecture. Your pumps can be smaller because you're moving less fluid. It can scale down other parts of the system as well relative to a single-phase system. And lastly, in some applications, this is an important one, is electrical isolation. The coolants that we typically use for pump two-phase are dielectrics, which means that they're not conducting electricity. So if you have especially some sort of power electronics, if these devices are power electronics, sometimes they can be running at a much higher voltage than the rest of the system. And all of this stuff might be connected to frames or whatever that's grounded. And with a water loop, you would need to have your device attached to a cold plate, and you'd need to build in some sort of electrical isolation here. Otherwise, the water going through this is going to conduct electricity through the rest of your system. And so doing it on that scale can be challenging. In the pump two-phase system, in addition to being challenging, this adds a thermal resistance that you have to conduct through to get to your coolant, which can be a negative as well. So eliminating both those things in a pump two-phase system, you have the dielectric fluid, so you can not worry about the fluid itself conducting the electricity, and then these lines can be replaced with a non-conductive hose, which allows you then to just isolate this section completely, and that can be at whatever voltage, and the rest of the system can be at whatever voltage. And so you have that nice isolation. If you would spring a leak as well, the fluid is going to evaporate. It's not going to throw water on your electronics. which is another benefit as well. So those are the primary benefits of pump two-phase over single-phase. All right.
Thanks for watching an episode of Engineers with Markers. We'd appreciate if you like this video and subscribe to our channel. Then make your way on down to the description for more resources. If you've got a question, leave it in the comments or visit the contact page on our website to talk with an engineer.